Hi everyone, in this video we'll be learning about consistent hashing, and we'll also see what is the benefit of consistent hashing over normal hashing. So let's get started. So in the last video we already learned about vertical scaling and horizontal scaling, and we also learned about sharding, but still let me give you a brief recap about that as well. So the thing is, let's say you have built any application and that application started getting lots of traffic. So obviously you need to scale your database server, this thing, right? So currently your database server has this specification. All right. So you have two options. You can either scale vertically or you can scale horizontally. So in order to scale vertically, you have to increase this specification. Okay. Like from 10 core, you can buy a server with 20 core CPU. Instead of 16 GB RAM, you can use 64 GB RAM and something like that. Okay. But problem over here is this specification cannot be increased infinitely. You cannot have infinite amount of storage, right? So that's the drawback, or you can say limitation of vertical scaling. So in such scenario, we move to horizontal scaling like this. Okay. So instead of using one database server, we'll be using many database server, right? So the total load is distributed among multiple database servers. Okay. So in order to horizontally scale any database, we need to basically split all the tables which are present in the database. Okay. For example, let's say I have this users table. So I have to split this user table between this database servers. Okay. That is, some rows would go over here, let's say in db1, some rows would go into db2, and some rows would go into db3. Okay. So this is what we have learned, and we also saw that how are we gonna split this table. So in order to split this table, we learned two things. First is we need to select a shard key, which is nothing but a column. Okay, we need to select a column on the basis of which we are going to split the table. And second is we need to select a sharding strategy. In sharding strategy, we learned these three things. Okay, directory based, range based, and hash based. But in the last video we learned this on a high level. Okay, so now is the time we are gonna study this little bit in depth. So before learning consistent hashing, let's first try to understand normal hashing. Okay. So this is the table which I want to split among three different database servers, right? So in order to split that, I will first select the shard key. So I've selected name column as the shard key, meaning I want to split this table based on the name column. Okay. Second thing is I'll be using normal hashing. Okay. This normal hash formula. I'm not using consistent hashing. So over here, I'll take hash value of the shard key and I'll mod that by n, where n is equals to 3. Okay. So first of all, let's see where this particular row would go. So in order to do that, I'll take hash value of ben. So hash value of ben is 2235, and then I'll mod that by 3. So I'll get 0 as the answer. It means that this row would go into db0. Similarly, this row would go into db1. Right. Now, if anyone tries to get the row corresponding to Ben, their read request will basically go to db0, right? Using the same formula. Okay. So one thing that should come into your mind is this hash formula is working perfectly, right? Then what's the need of using something else? Like what's the need of using consistent hashing? So let me tell you that. See, earlier we had 3 database server, but now we have 4 database server. Okay. So this n value will change, right? So now if someone tries to perform this read query, first of all, this hash value of Ben will be taken, which is 2235. And then instead of modding that by 3, we are going to mod that number by 4, which is giving me 3, right? So this query, this particular query will be redirected to db3, which is this database server. But in reality, that particular data, that is this row, was present into db0, right? So it means that we have to redistribute all the data because we have added one more server. Okay, so this is one drawback. If I want to just add one server, I have to redistribute all the data. All the data into this DB0, DB1 and DB2 is supposed to be redistributed, and that's the problem. And this problem also happens when I try to remove the database server. Okay, so over here, let's say I just want only two database server because they are sufficient in handling the load. So again, this n will change, right? So since n has changed, this particular value is also getting different, right? So now if someone tries to get the data of Ben, their read request will go to DB1, but in reality, it was stored into DB0, right? So this is the major drawback. So while adding or removing any database servers, you have to perform a computationally heavy redistribution. Okay, it has a lot of impact on performance and bandwidth, which is not good. So whatever problems which we discussed just now can easily be prevented using consistent hashing. In consistent hashing, you would be having this imaginary ring. All right, it will just be present into your code. Okay, and on this ring you would be having the points. This points represents the hash value. So hash value basically returns an integer, right, from 0 to the power 32. So that's why this particular points would also range from 0 to 2 to the power 32. But just for explanation purpose, I've just taken this points from 0 to 95 or 100. Okay, so again you'll do the same thing, that is you'll take the hash value of Ben. Okay, but the thing is you won't mod this value by 4 or any number of database servers which you have. Okay, whatever value you are gonna get over here, let's say you got 15, so whatever value you are gonna get, you would just move clockwise from that value. Okay, and whatever database you are gonna encounter, that is the place where you would be storing this Ben, data corresponding to Ben, right? And if you want to perform a read request, same flow would be executed. That is, first hash value of Ben will be taken. Let's say it's 15. Again, you will go in the clockwise direction and fetch that value from this DB2. That's it. So this is how the consistent hashing works. The benefit of this consistent hashing over normal hashing is seen when you try to remove or add a database server. So let's see that. So let's say I want to add a database server 5. Okay, this database server 5 can be added at any point. You can even add that on point 60, 65 or anywhere you want. Okay, so let's say I wanted to add this database 5 at point 40. Then whatever data was present in DB3, right? So this DB3 was having data from 25 to 50, right? So now since I have introduced DB5 over here, so data from 25 to 40, which was present in DB3, will be moved from DB3 to DB5. That's it. So this is the only thing which you are gonna do. Earlier, we were performing the redistribution of entire database. So the data from all the database servers was getting redistributed, but that is not going to happen now, right? Similarly, while removing the database server, you would just move the data from 0 to 25 to database 3. That's it. Okay. You are not gonna perform the entire redistribution. But over here, there's a problem. The problem is, if I remove this DB2, then I have to move all the data from 0 to 25 from DB2 to DB3, right? So this DB3 will be having 2x amount of data compared to DB4 or DB1, right? So the data distribution is now uneven because I removed this DB2. So in order to solve this problem, we have a concept of virtual nodes. So instead of having the physical database servers, we also place some virtual database nodes as well on this particular ring. Like for example, DB1 originally is present at 0, but apart from that it's virtually present at 0.20, 0.40, 0.60, 0.80, and so on and so forth. Similarly for all the other nodes as well. The benefit of using this concept of virtual node is, now if I remove this db2, okay, so let's remove this db2. So now if I remove this db2, the data from 0 to 10 will go into db3. Okay, so by the way, this is also removed because this virtual node corresponds to the original db2 node, right? So the data from 0 to 10 will go into this db3, 10 to 15 will go into db4, 15 to 20 into db1, and 20 to 30 will go into db3. So now the total data distribution will be even. Over here it was uneven, but since we are using this concept of virtual node, the data distribution is now even. So obviously the load distribution will also be even now. Okay, so in this video we studied the benefits of consistent hashing over normal hashing, and we also studied the concept of virtual nodes and how they help us to evenly distribute the data among multiple database servers. Okay, so if you found this video helpful, then please like the video and share this video with your friends. Thanks for watching.